Good evening, students. Today we are going to see the fifth unit, column base. Here you are seeing the I section angle in which the two plates has been provided, and here it is the column base elevation, that is, this is the foundation details of the concrete, this is the base plate, this is the column base, and this is the column, right? So here you can see the foundation details, here the total concrete area, and this is the column base, and this is the I section where the column is going to be provided, right? So today we are going to see a problem which is a rolled steel column, a 3.5 meter high ISHB 250 at 57.4. This is the column section. Column carries service axial load, shear load of, this axial load is 1700 kilonewton. The column is should able to carry 1700 kilonewton, and the shear capacity is 60 kilonewton respectively. Design a suitable base plate over M25 concrete block. The safe bearing capacity of the soil is given as 250 kilonewton per meter square. Use 20 mm diameter 4.6 grade bolts. So in this problem they have asked to find the design a suitable base plate. They have asked to find the suitable base plate with concrete block. We have to design. The bolt size has been given, safe bearing capacity of soil has been given, axial load is given, shear load is given, and the column they are going to use, the section is also given. Okay, coming to the problem. So you all know very well that whenever a section is given, we should know the properties of the section. So here h is equal to 250, height, breadth of flange, thickness of flange, thickness of web, area, and R minimum. Everything you can take it by using the steel tables. It is ISHB, so it is a I section. Next we have to calculate the axial load. Axial load is given, we have to find the factored load. 1.5 into 1700 will give you 2250, and we are assuming the column size as 250 by 250 because the base of flange is given as 250 mm. Hence we are assuming the column size as 250 by 250 mm. A square base plate may be considered. Now we have to find the area of the BP is nothing but area of the base plate. We know the axial load given divided by 0.45 into FCK. FCK is nothing but the characteristic compressive strength of concrete. In the problem itself, it is given as M25 concrete block. Hence, PU by 0.45 into 25 will give you this area of the base plate. We are considering it is a square plate. Hence, if you take it as a root, it will be giving 476.5, approximately 500 mm. So recommending anchor bolts considering 550 by 550 mm base plate with the area of this much. We are increasing the base plate so that the cleat cover sides should be some between the column. There should be some bearing between the sides of the column. Hence we are increasing the size of the base plate. The properties of two dimensions is, that is 550 minus 250 by 2, which is 250 is nothing but the size of the column which we have assumed based on this flange width, and it is two sides, the bearing I have already told should be 150 mm. The intensity of pressure of base plate PU is equal to PU by APB, which is, we know very well, 1700 is multiplied by 1.5, which is 2550 divided by the area of the base plate will give you 8.43, which is the pressure which may take. The thickness of the base plate can be obtained from the equation. This equation is available in page number 47 of 7.4.3.1 in IS 800 2007. So in that a formula is given. I will show you the formula. One second, I will show you the formula. So the formula is, says, the formula is TP is equal to root of 2.5 PU AT square minus 0.3 B square divided by Fy into gamma m naught should be less than or equal to thickness of flange. Here, based on that formula, 2.5 into PU is the pressure intensity 8.43 into A square. A square is nothing but 150, which is the two directions. Here it is a square column, hence A and B are same. If it is a rectangular column, we have to calculate the another side also. So 150 square minus 0.3 into b square, b is also 150 square, divided by Fy is 250 divided by gamma m0 is 1.1, in which you can find the 38.44 mm, say approximately 40 mm. As per the codal provision, it should not be less than thickness of flange. Our thickness of flange is 9.7 mm, hence it is okay. So now we are considering the base plate size as 50 by 50 by 40 mm thick. So we have to check whether the base plate size given is effective area. By using this effective area method, we have to check whether we have given the base plate size is correct or not. Considering an overlap, equate every effective area to the required thickness. Area effective is equal to 4c square. That means 4 sides the column square plus periphery of the column plus area of the column. 4c square plus 4 into h is the height. Sorry, it is not height, it is actually 4 sides of the column, and 2 into thickness of web plus 2 into thickness of flange plus area of the column. So by doing this, you will be getting the c value. C is nothing but the considering the overlap. I will show you in figure how the overlapping will occur. One second. One second, students. Yes. So you can see the overlapping here. Here it is the size of the column, and here you can see here clearly that I think the picture is not clear now. You are getting clear? Clear? Yes. I'll show you. This is the overlapping. To C is this sides and this sides. So coming to the problem, we will see. Coming to the problem, we will see the C value, and C is 113.46. Again, we are checking whether 113.46 is correct or not. H minus 2 TF by 2. This is the thumb rule, in which H is the height of the I section. 2 into thickness of flange divided by 2 will give you 115, which is greater than this. So hence we have to increase the C, and then based on that base BF is flange width plus 2 into C. C we have calculated is 113.6. So 250 plus 113.6 will give you 476.92, which is less than dp, which is equal to 550 mm. Hence the calculated value of C is valid. The thickness of base plate also we have to check. So C into 3 into 4.45 FCK divided by FYP gamma and not root. So here C value is 113.6. I will substitute all the values. FCK is 25 and 1.1 will give you 43. But we have provided 40 mm. It is not enough for the thickness of plate. Hence it should be increased. Hence we are increasing the base plate as 50 by 50 by 44 mm thick base plate. Next, coming to the column to the base plate, we have to consider the shear force also. So the shear value in the question, it is given as 60. So increasing the factored value into 1.5 into 60, which is 90. Therefore we are considering 100 mm length of 6 mm fillet weld. We are assuming it as 6 mm fillet weld with 100 mm length, and the effective length of the weld we have to calculate. Effective length of the weld is equal to 2 into L minus 2S. S is the size of the weld, and L is the length. We have assumed it as 10, so which is 176. So effective length is 176, and we should check whether the shear strength of the weld is enough or not. So 0.75 S LCW into Fu by root 3 divided by gamma MW. 6 is the size of the fillet weld, L is the length, and 410 is Fu, and root 3 by 1.25 will give you 139.98. But we required only 90, hence it is okay. So we can provide 100 mm length 6 mm fillet weld on the website. Connection to the base plate to the concrete block. So below the base plate we have to provide the concrete block. The axially loaded plate can be anchored by concrete block using 40 mm 400 long anchored bolts of 20 mm diameter is given in the question. So load is 1700. So by safer side we are allowing it as 15%. So 1500 to 1.175, 1.15 will give you 1955. 1955 divided by SBC, safe bearing capacity of the soil, is given. Because all the load will be going to the soil only, hence we have to consider this, which will give you 7.82. So this is the calculation. That means it is in kilonewton. It is in kilonewton per meter square. It will be giving meter square. That means the area of the concrete block. So we are getting 7.82 meter square. So 2.8 by 2.8 size of the concrete block can be considered, and depth of the concrete block may be taken as 2.8 is the size of the concrete block minus 0.55 is the column size, will give you 1.125, so approximately 1.15 meters. So adopt 2.8 by 2.8 by 1.15 deep concrete block for the foundation. That's all, students. Take care. Be safe in the home. Thank you.